All right, so in this video, we're gonna go over a couple of practice problems to measure how many calories is in our butter, and then to do one more problem that you'll see more likely in your quizzes, right? So the main thing you just need to know is the equation to calculate calories that I've placed here, right? We know that Q represents how many calories we can calculate. M is the mass of the food that burned. C is the specific heat of water, or 1, right? It's always going to be 1 because basically it makes our math easier, and we know the specific heat of water. We don't always know the specific heats of the calories of the food. But when we burn our food, we can transfer all of that heat into water, and that's why we can use this equation, right? And then lastly, we need to know the change in temperature for the item that we burned, right? In this case, it's the butter. So talking about the mass of the food burned, we know that our starting mass is 16.11. And after the food burned, when we weighed it again, the mass was 15.01. Because I only care about the mass of the food that burned, I'm going to subtract these two numbers. So my mass is actually going to be 1.1. Right, so I'm only going to subtract if not all of the food burned, right? So in this case, from the last video, not all of the food burned. That's why my mass is 1.1. My specific heats is going to be the same number every single time, as long as I use a calorimeter that heats up water. And most of them do that. So my C is always going to be 1. Specifically, the units for that is going to be calories per gram times degrees Celsius, right? And then finally, our change in temperature is always going to be our final temperature subtracted from our starting or initial temperature, right? So for this problem, it's going to be 13.2 after I subtract these two. So my change in temperature, right? So change is represented by this delta or triangle T, right? But really this whole color means that it's one number. So our change in temperature when we subtract them is going to be 13.2 degrees. So at this point, when I have all these numbers, I can plug everything into my equation and solve. All right, so it's going to be 1.1 times 1, our C, times our change in temperature, 13.2. So when I calculate all those things, right, in my handy dandy calculator, I will get 14.52 lowercase calories, right? So remember I mentioned at the end of the last video that this is not what you see in the nutrition facts, right? This is actually much smaller than the calories we see in the nutrition facts. So let's work on a problem that's a little more realistic. Okay, so this time for this particular problem, notice that I have a 5-gram sample of cheese. So I know that my starting mass of the cheese is 5 grams. So let me actually change this to green so it matches the units. Whoa. 5 grams. Right. This is my mass so far of cheese that raises the temperature of the water from 20 to 42 degrees. So my temperature is going from 42, and then before it was 20. So I'm going to subtract these two numbers, taking the larger number first, smaller number second, right? Or the ending number first and the starting number second, right? So 42 minus 20 is going to be 20. So my temperature change is going to be 20 degrees Celsius, right? Assuming all of the contents of the cheese have burned off. So there's none of the cheese left, all of it burned off, all 5 grams. So we don't need to do anything with this in this case. How many calories can be found in the cheese, right? So I have my part in green and I have my part in red, but I'm missing this part in purple. But if you remember, it's always going to be the specific heat of water, which is always 1. So our specific heat, or C, is always going to be 1. So same thing as before, right? Step 1 was just labeling all of our parts, looking for mass, specific heat, and change in temperature. Part 2, we're just going to multiply everything together, right? So it's going to be 5 times 1 times our change in temperature. So subtracting these two, oops, I just realized that this should be 22. 42 minus 20 is not 20, it is 22. So 22, 5 times 1 times 22 will give me 110 lowercase c calories, right? So remember that lowercase c calories are different from capital C calories. And the second part of this question asks, how many capital C calories would be listed on the nutrition facts label? So in class and briefly in the video, I mentioned that all the calories you see in your nutrition facts are in capital C. And that's because 1,000 lowercase c calories is equal to 1 capital C calorie. You might ask, why use the same name for 2 different units? And that's because it has a lot to do with marketing. If I told you that this actually is 230,000 calories, it might freak you out a little bit and make you not want to buy this food. So the units mean something different when they're a capital letter, but it's not very explicit. If you ever go to Europe or sometimes in literally any other country, you might also see the labels be a little bit different, right? Sometimes you'll see that the nutrition facts in Europe is it'll say K calories, so kilocalories. The K is to signify that it is 1,000 times more, right? But anyways, that's kind of a side note. So to answer our second question, how many capital C calories would be listed on the nutrition facts label? Well, I know that for 110 calories, right, one capital C calorie means 1,000 lowercase c calories. So to find out how many capital C calories it is, I just need to divide by 1,000. Right, so 110 divided by 1,000 will give me 0.110 capital C calories. So if this number is less than 0.5 on the nutrition facts label, it will be counted as 0 calories, meaning it is calorie free, although that is technically not true. So things that are labeled as calorie free or 0 calories isn't always true. It just means that they have less than 500 lowercase c calories or regular calories. Right? So these are 2 practice problems that I went over with you. On the next slide, you'll find more practice problems that are very similar to this, and they get increasingly harder as you go down the type of problems. And then the slide after that is the answer key for you to double check your answer. Make sure you know how to solve them, because on your launch on Thursday, you'll find that we're going to have a lot of very similar problems on the launch.